Today we're going to take a look at complex fractions, and as a reminder, we've already talked about this, but just as a reminder about what division actually can be thought of as, is division is the same as multiplying by the reciprocal. We've done this already with fractions this semester. We've seen it from the perspective like this, where we would say something like 1/2 divided by 3/4, and we change that to what? What would that be the same as? 1/2 divided by 3/4.
1/2 times 4/3.
Right, times 4/3. We flip the second fraction, right? That's all we're doing today. That's it. They're going to look a little bit different than that, but it's going to be the same process over and over and over again. There's going to be one set of problems that are going to be a little bit unique because they aren't going to actually look like a fraction divided by a fraction at the beginning. So let's take a look at some pretty straightforward ones with just numbers. Now what you notice here, this is what's called a complex fraction. It looks like a fraction inside of a fraction. Okay, so that phrase complex fraction means this. Now, if you really write it differently, it looks much more like what you've seen before. This is 5/3 divided by 3. Is everybody good with the fact that we've done that before? Right? You've seen problems start out this way. And you know that division is the same as multiplying by the reciprocal. So I can change the division to multiplication. And then what's the reciprocal of 3? 1/3. And it becomes simply fraction multiplication. So what would this multiplication give us? 5/9. Okay? It's the same thing. It just looked different at the very beginning. So let's give the next one a try. You don't necessarily have to rewrite it this way. I'm just going to do it one more time, just as a reminder. But this is really 3/5 divided by 9/14. That's what it is, just written in the form that you're used to seeing it. So if we write it then as multiplication, what would it look like? Right, 3/5 times 14/9. Now if you want, you can multiply across and then reduce, or you can look at the reducing now. I'm kind of a fan of reducing before I multiply. So if I look at this diagonal in particular, the 3 and the 9, what do they have in common? A 3. 3 divided by 3 is 1, and 9 divided by 3 is 3. Now, what about the other diagonal? No, there's nothing there. So, we would simply multiply across the top to give me 14, and the bottom to give me 15. You got it. Okay. So, the only difference between this and what we've done before is how the problem looked at the beginning. That's it. The next ones, I can't remember if we've seen ones like this before. I'm starting to mix this class up with another one I'm teaching, so you can tell me. Have you seen portions of problems where there's whole number parts and mixed number parts or proper fraction parts? No? I don't feel like we've seen this before. Okay, here's what I'd like for you to recognize though. There are little denominators that are present here, right? What are the little denominators, right? Not the big overall denominator, but the little denominators that are present in this first problem. There's a 1 and a 2. I don't see a 2 on this one. Denominators. 5 and 4. Yeah, there's a 1 here too. Like this is 1/1, this is 2/1.
Oh, yeah.
Yeah, is everybody good with that? So there's really like 4 denominators here. There's a 1, a 5, a 4, and a 1. Everybody good with that? Okay. So here's what we're going to do. And we did this process, but with a different starting point before. We're going to find the least common denominator of the denominators that are present. So in particular, the 1 doesn't matter. It's just the 4 and the 5. What is the least common multiple or the least common denominator if you consider 4 and 5? It's 20. Right? They don't have anything in common, so we just multiply 4 times 5 Whoops. Or 5 times 4 is what I wrote, and that's 20. So we're going to multiply the top and the bottom by 20. But let me take a moment to see that written differently. We did this when we were dealing with fractions inside of equations. And we talked about the fact that, man, it'd just be really nice if we could get rid of the fractions inside of the equations. And we did it this way. We said, what's the least common denominator of all the fractions? And let's just multiply by it. Okay? This is the same thing we did before, just with a different context. So what I have to do is I have to multiply whatever my number I'm using 20, by each number. So this is 20 times 1 minus 20 times 7/5 over 20 times 7/4 minus 20 times 2. Please write it out that way. You're going to find it so much easier to not forget to multiply that 20 somewhere if you just write them all down. So much easier. So let's go through the pieces of this. The first one, 20 times 1, that's 20, right? Let's look at this piece right here. What happens when I have 20 here? Yeah, you can think of it, if it helps you, as 20 over 1, right? The 20 reduces with the 5, or don't do it that way. But it's either way. Yeah, you're going to reduce the 20 and the 5. What's 20 divided by 5? 4. So now I have 4 times 7. It's a negative because there's a subtraction sign there. And what's 4 times 7? 28. Okay, and the denominator, we're at this one now. Right. The 20 divides by the 5. These are always going to turn into whole numbers. I mean, that's not a surprise. They're going to turn into whole numbers because we chose the least common denominator. Okay? So it's always going to divide. 20 can divide by the 4 to give me a 5. 5 times the 7. You can hardly tell it's a 7 now since I keep marking things up, but it is a 7. 5 times the 7 that's there would be 35. And the last two is whole number multiplication. 20 times 2 would give me 40, and it's subtraction again. So now we've got just subtraction of numbers, right? What's 20 minus 28? Negative 8. And what is 35 minus 40? Was it minus or was it plus? I switched it here. There we go. Positive, positive. Get those fixed since I made that mistake. Thank you. 35 plus 40, 75. Okay. So I feel like we should practice another one. Take a look at all the little denominators. And what I need to know is, what is the least common denominator when you consider all the little ones? It's actually 20 again, and when that happened in my notes, I almost went back and changed the problem, but I thought, you know what, you guys can be okay with it. It's not always 20. Everybody understands that, right? Okay, it's not always 20. I just happen to choose 2 examples where it is. Okay, we're going to multiply top and bottom by 20, which means every piece gets multiplied by 20. So I have 20 times 6 over 5 minus 20 times 5 over 2 all over 20 times 3 over 2 minus 20 times 5 over 4. I try to help you out by telling you when you do and don't have to write things out. Please write the 20s out here, okay? You're just going to have so much better luck at not forgetting one piece of it if you do. Now again, the reason we chose 20 is because all of the 20s are going to make the denominators cancel. So this 20 and this 5, 20 divided by 5 is 4. And then I have 4 times 6 giving me 24. Second part of my numerator, I have 20 and I have divided by 2. That's 10. So then I have the 10 times the 5, so I have negative 50. First piece of the denominator, I have another 22. 20 divided by 2. So that's a 10. Now the 10 is times the 3. so it's 30. This time I do have a subtraction sign. I didn't just imagine it. I have 20 divided by 4, which gives me a 5. So then I have a 5 times 5 giving me a 25. What do I get if I subtract the numerator? Negative 26. And if I subtract the denominator, 5. And just like before, improper fractions are totally fine, no problem. And 26 and 5 have nothing in common, right? So we're good to leave it. Ready to see another one? Okay. Now we got some variables. Now, on number 5 and on number 6, what you should notice is that it's completely a fraction on top and a fraction on bottom. This problem is like problems 1 and 2. Right? Totally a fraction, totally a whole number, or a fraction on bottom. It's not like 3 and 4 where there's this whole number piece and this fractional piece. Does everybody see that okay? It's easier to deal with it that way. When there's a total fraction and a total fraction, all I have to do is write them as division beside each other and then flip to multiply. So I can do that with this problem. Whoops. I can rewrite it or not. I mean, I don't have to write this step, but I think at least for now it's probably helpful to see it. This is x plus 4 over x minus 5 divided by x plus 4 over 5x to the 4th. Right? That's what it is, because it's a fraction divided by a fraction. And when you have division of fractions, you can rewrite them as what? Multiplication, right? So instead of division of x plus 4 over 5x to the 4th, what will it be multiplication by? Right, 5x to the 4th over x plus 4. And consider diagonals, right? Let's do this diagonal first. Anything on that diagonal can simplify. Nope, it can't. What about my other diagonal? Absolutely, right? They're identical, so they cancel out. And I'm left with 5x to the 4th on top and x minus 5 on bottom. Okay, give the next one a try. Try number 6 for me. And then check in with a neighbor and see if you got the same thing. As you find yourself nearing the end of your problem, check with a neighbor.
simplify those two, can't you?
You can, but it won't do it quite the way you did. You're close. Here, let's see, I can turn around upside down.
So I got that to 4 over 5x and 2.
Yeah, this 2 has to be simplified as well.
Oh.
That will change a little bit, but you're on the right track. Okay, it looks like you guys have got some of the good things going on to start with. So what did you do first? Did the reciprocal. So if you want to skip my step that I keep writing just to remind you what we're doing, you can rewrite this as multiplication by the reciprocal right away. Does everybody understand what I mean by that? Okay, so if you need to see this step, please write it. But if you don't need to see it, don't write it. It's fine. I need to multiply this by the reciprocal, which would actually have a 2 on top and a 2x minus 10 on bottom. Are we good with that?
Yes.
Awesome. Okay, let's look at diagonals. How about this diagonal? Nope, nothing there. How about this diagonal? It actually reduces, or you could reduce this fraction. Do you see lots of even stuff? Yeah. Let me just reduce this fraction, just because that's where it's already written. But if you reduce the diagonal, it'll be fine. So here's what we're going to do. Everything's even, which means everything can be divided by 2. So I could actually divide 2 by 2 to get 1, 2 by 2 here to get 1, and 10 by 2 to get 5. And then I can multiply across the top. So 8 times 1 would be 8. And then I have 5x times 1 would give me, 1x. That's an x there too. So it would give me 5x squared. Or you know what? I don't even have to write it that way. We can just write it like this. Here's your 5x. And then you have x minus 5. If you want to distribute it, you can, but you don't have to. Right? 5x at the beginning, x minus 5 on the second fraction. If you had chosen, this is what Preston and I were looking at, if you'd chosen to distribute or to simplify that diagonal, that's a fine too. You would have ended up getting, I'll just write it out below, a 4, because it would have divided by 2. And you would have gotten that same 2 on top, and you would have still gotten that x minus 5 on bottom. And so your 8 would still come about because you would end up multiplying these two together. Everybody good with that? Okay, cool. Okay, let's try another one. You guys are doing good with the multiplying by the reciprocal part, so I'm going to flip that initially. So this is 7x minus 49 over x times what? Good. X minus 2, Trey. What do you have next? Over 4x minus 28. So let's start with the easy diagonal. This one, it's got less going on. Anything that I can reduce there? Nope, because they're terms, not factors, right? No reducing I can do in that step. But on this one, it's much harder to look at that, the way it's written, and say yes or no, isn't it? It is. So in order to do it, we're going to have to actually take each piece and factor it. So let's consider the 7x minus 49. Do either of those pieces, do those two pieces, I should say, have anything in common? Yeah, a 7. So if I take out a 7, what am I going to be left with? X minus 7, very good. Let's do the same thing on the bottom over here with 4x minus 28. Do they have anything in common? 4. The 4. And if I take out a 4, what am I left with? X minus 7. And do you see now something that the two pieces have in common? Yeah, the x minus 7, right? Is everybody good with that? So what I have left? Well, I have a 7 here. I have an x minus 2 on the next fraction, over. I have an x here and a 4, so it's 4x. Any questions on that one? That one was more complicated than the one we did before. Okay, how does number 8 look different than the last 3 problems that we just did? The variable, what was that? There's a variable in a portion of the denominator. What else? Say it again, L'Oreal. The fractions happen to match. That's true. Say again, Keely. The 7 and 3, what about them? They're alone. This problem should actually feel more like 3. Did I write the right one? Yeah, like problem number 3. It looks a lot like problem number 3, actually. Where I've got a whole number part and I've got a fractional part. It looks maybe a little bit less like number 4, but it's kind of like number 4. It's not like 5 and 6 and 7 because on all those problems, it's a single fraction on top, single fraction on bottom, divided. Right? I've got a portion of a fraction and something else on top, and I've got something and a portion of a fraction on bottom. So this question will work out much more like 3 and 4 than it does like the other ones where there's a fraction and a fraction. Okay? So what did we do on 3 and 4? We found a least common denominator. And one of you guys told me what it actually is on this problem. What is the least common denominator from all the denominators present here? It's W. Not real exciting. It's only one thing, right? But really, there's 2 denominators present. There's a W and there's a 1, right? There's W's and 1's. So the cool thing is, on this one, I actually get to multiply simply by W on the top and the bottom. And when we did this, I told you before, whatever I'm multiplying by, I want to write it down as multiplication by each part. This time it happens to be a variable. So I have W times 2 over W plus W times 7 over W times 3 plus W times 2 over W. It's just like my 20s, right? 20 times each piece. I have W's times each piece. And because it's the least common denominator, the whole point is it's going to eliminate the denominators I have. So this W and this W cancel, leaving me with what? 2. The other piece would be more naturally written as 7W. And on the denominator, 3W. What happens to the W over times 2 over W? They cancel again, leaving me with a 2, right? Can I do any reducing from the numerator to the denominator? There are 2 2's, but not every number is divisible by 2, right? So if all of them were even, we could divide all of them. But because I only have a couple of them even, I can't do anything about that. All of them don't have a W in them either, right? 2 of them do, but not all of them. So there's actually nothing else, whoops, meant to get a black, nothing else that I can do on this problem to reduce it any further. But let's be honest, doesn't it look a whole lot better than it started out looking? It really does. Complex fractions, where there's got fractions inside of fractions, are just messy looking. And all we're doing is simplifying what they look like so that we can work with them later, actually in college algebra. Okay? All right.